Hello, this is Brett from SurvivalComms, and today we're going to talk about building a battery bank and basically wiring batteries in series and parallel and what it means.
So when we wire batteries in series, we get a voltage increase, but we get no increase in capacity. So as we can see, we have two alkaline batteries here, and we've tied the positive and negative terminals of the two cells together. And if we take a multimeter and place that on the positive and negative terminals on the opposite end of the battery, we'll have 3 volts. So basically what we've done is we've doubled the voltage of the two individual cells in the circuit. On a lead acid battery such as this, what we've done is internally in the battery, they've actually taken and they've tied each individual cell together, and the 6 cells tied together in series provide 13.2 volts. Another example is with these two 18650 lithium-ion batteries that are wired in series. Now, each one of these batteries provides 3.7 volts. Since they're wired in series, if I measure the power output at this terminal here, it'll be 7.4 volts. However, there's going to be no capacity increase, so the capacity of this pack is only going to be 8.14 watt hours, or the capacity of an individual cell. Wiring batteries in parallel is what you see when someone's building a battery bank. Essentially, they want to increase the capacity without increasing the voltage. So in this example here, we have 4 12-volt cells. What we do is we just tie the positives together and then pull our positive off of one end, and we do the same to the negatives and pull our negative off. And what we've done is we have 12 volts available, but we've increased our capacity to 80 amp hours. Now let's put together what we know and build ourselves a battery bank out of 6-volt golf cart batteries. So what we have here is we have 6-volt, 200 amp hour capacity golf cart batteries. Now we want to make this into a 12-volt battery bank. What we would do at first is we would just go ahead and tie each pair of 6-volt batteries together in series, and that's going to give us 12 volts at 200 amp hours of capacity. So now, very simply, to complete our bank, we're going to take our 3 12-volt batteries that we've built by series wiring the 6-volt batteries together with their unused positive and negative terminals. We're going to tie all the positive terminals together, all the negative terminals together, and then take those leads and bring it to our load. And this will provide us with a 12-volt battery with a 600 amp hour capacity. Here's an example of our combination system. Each one of these batteries that's in here is a 6-volt golf cart battery, and this is pretty consistent whenever you see a battery bank constructed out of 6-volt batteries. So what we've done is we've taken 2 6-volt batteries and tie them together or wire them in series, and that gives us a 12-volt battery. Now we parallel 3 of these series wired 12-volt batteries together to give us 12 volts, but our capacity now is 600 amp hours. When we talk about battery capacity or battery bank capacity, I typically prefer amp hours as a measure of capacity. Some people prefer watt hours. If you wanted to convert amp hours to watt hours, it's pretty simple. You just take the amount of amp hours and multiply it times the voltage. So you can see that battery bank that I just showed you outside is 7,200 watt hours at 12 volts. And in review, batteries in series increase voltage but do not increase storage capacity. Batteries wired in parallel increase capacity but do not increase voltage. I hope this helps. This is Brett from SurvivalComms. Till next time.